All right, any questions on numbers 1 or 2?
May you do too?
Yes. All right, so number 2 says find the area bounded by the graphs of f of x is sine x and g of x is cosine x on the interval 0 to pi over 2. So I'm going to sketch my graph. This is a non-calculator question. Okay, so here's 0 and here's pi over 2. So the sine graph is going to start at 0, 0. It's going to go up, and then it's going to turn, and at pi over 2, that's not right. I'm thinking my sine graph. Sine graph is going to go from, let's start all over. Here's 0, and sine is going to go to pi over 2 and be up here. Okay, so here's pi over 2. It's at 1 at pi over 2. Cosine is going to start at 0, 1, and at pi over 2, it's going to go here. Okay, so we're doing that. So the two graphs are going to intersect, and where they intersect is this point right here at pi over 4. Okay, because we know that the sine and the cosine of pi over 4 are both radical 2 over 2. So that's what this would be right here. Okay, so we're talking about the area between here, and we're talking about the area between here that we want to find. Okay, so there's two integrals that you have to set up. I'm going to set them up individually, but you're just adding them up. So the first integral is the integral 0 to pi over 4, and the graph on top is cosine, so it's cosine minus sine. The other integral is going to go from pi over 4 to pi over 2, and the sine graph is on top, the cosine graph is on bottom, so it's sine minus cosine dx. Okay, so I'll just do them individually. This one right here, the antiderivative of cosine is sine, and the antiderivative of negative sine is cosine. Okay, because the derivative of cosine is negative sine. And we're doing that one from 0 to pi over 4. So it's the sine of pi over 4 plus the cosine of pi over 4 minus the sine of 0 plus the cosine of 0. So that's just doing this one integral. The sine of pi over 4 is radical 2 over 2. The cosine of pi over 4 is radical 2 over 2. The sine of 0 is 0, and the cosine of 0 is 1, so it's going to be minus 1. Radical 2 over 2 plus radical 2 over 2 is 2 radical 2 over 2, or just radical 2 minus 1. So that's what the area of my left part is equal to. And then going to this one, the antiderivative of sine is negative cosine, and the antiderivative of negative cosine is negative sine. And we're doing that one from pi over 4 to pi over 2. So fundamental theorem of calculus part 1 would be negative cosine of pi over 2 minus the sine of pi over 2 minus negative cosine pi over 4 minus the sine of pi over 4. Kind of got scrunched there at the end. All right, so the cosine of pi over 2 is 0, so you get 0 for the first one. The sine of pi over 2 is 1, but it's negated, so you get negative 1. The cosine of pi over 4 is radical 2 over 2, and it's double negative, so it's going to be a positive radical 2 over 2. And the sine of pi over 4 is radical 2 over 2, double negated is radical 2 over 2. So this gives me -1 plus radical 2. And then I'm adding these two answers. So radical 2 plus radical 2 is 2 radical 2. And -1 plus -1 is -2. All right, I don't know if the issue was with the derivative, with the setup, or with the plugging in. You'll have to figure that out, obviously.
Could you do one, please? I think it's just in my math wrong.
Okay. Did you have, well, first we got a picture, right? And we have x squared minus 1, looks something like that. Negative x plus 2 is going to look something like that, okay? So this is at 1, and this is at 0. So we're just finding this area right here. So our integral is going to be from 0 to 1. They told us our interval, so that makes it a little easier. And the line is on top. So it's negative x plus 2 minus x squared dx. So I would rewrite it just to make it go in a descending order. Negative x squared minus x plus 2 dx. And then I would take my antiderivative. So my antiderivative is -1/3 x cubed minus 1/2 x squared plus 2x from 0 to 1. And I'm going to just plug this in my head. I know that the second part is all going to be 0, so I'm just plugging a 1 in. So it's going to be -1/3 minus 1/2 plus 2. So if I change everybody to sixths, that becomes -2/6. That becomes -3/6, and this becomes 12/6.
Mess on.
Yeah, did I mess up?
What happened to the, because it's x squared minus 1?
Yeah, I did the wrong derivative, didn't I? I just thought it was x squared. So it should have been +1 here. So my function should have been 0 to 1, negative x squared minus x plus 3 dx. Thank you very much. All right, so antiderivative is -1/3 x squared minus 1/2 x squared plus 3x from 0 to 1. Much better. So it's -1/3 minus 1/2 plus 3. So everything was right except the plus 3 on the end there. So this is -2/6, this is -3/6, and this is 18/6 now instead of 12. And that gives you 13/6. Final answer. All right, let's go on to 3 and 4. Questions on 3 or 4?
Could you do both of them, please?
Yep. Are we having trouble with the math, or are we having trouble with the calculus part of it?
I think I did my math wrong on 3, but I just don't know what to do for 4.
Okay, what's your antiderivative for 3?
-1/3 x cubed minus 1/2 x squared plus 6x.
That's correct. Yeah, you're just messing up some math. Okay, so it's -1/3, that's an x cubed, can't read that, times 2 cubed minus 1/2 times 2 squared plus 6 times 2 minus -1/3 times -3 cubed minus 1/2 times -3 squared plus 6 times -3. So this is -8/3. This is -2, and this is 12. Minus, this is -27 times negative 1/3 is 9. This is 9 times negative 1/2, which is negative 9/2. And this is negative 18. So,
I figured it out.
all right, no
I had
problem.
a plus sign instead of a minus sign.
Got you. All right, so 4 was obviously, I think, was probably the hardest one. Okay, so and you will see something like this more than just right here. Okay, sometimes it does a horizontal line, sometimes it does a vertical line, but the graph of y equals the square root of x looks something like that. Okay, the line y equals 0 is the x-axis. The line x equals 4 is this line right here. And the line x equals 4, let me make sure I read this correctly. The vertical line x equals k. Okay, so x equals k divides this area. If I shaded this in, let me just do that with a highlighter. Okay, if I shade all this in, okay, that's the area I'm talking about. The line x equals k divides this into 2 equal regions. Okay, so I have this line right here, which is x equals k. And this area is equal to this area. Obviously not in my picture, but that's not the point. Okay, and it asks us to find the value of k. Let's forget about the line x equals k for a minute and find the area of the region. That'd be the first thing we want to do. So the area of the region is from 0 to 4, the integral from 0 to 4 on square root of x dx. That's just the one function. Okay, the square root of x is really x to the 1/2. Okay, so we'll take our antiderivative, and the antiderivative of x to the 1/2 is 2/3 x to the 3/2. Okay, we're going to add 1 to 1/2 and get 3/2. That's how I get this exponent. And we're going to divide by 3/2, which means multiply by 2/3. And we're going to do that from 0 to 4. Okay, so I'm going to find the area of this whole entire region by doing this integral. Okay, so I'm going to do the fundamental theorem of calculus part 1, which is 2/3 4 to the 3/2 minus 2/3 0 to the 3/2, which we know is 0. So 4 to the 3/2 means the square root of 4 cubed. Okay, so the square root of 4 is 2. 2 cubed is 8. So this whole thing equals 8 times 2/3 is 16/3. Okay, so the area of the whole entire pink region is 16/3. Well, if that's true, this is 8/3 and this is 8/3 because it divides it equally, right? And 8/3 plus 8/3 is 16/3. Or I could have just done half of this, right? Not divide by half, but multiply by half and get 8/3. Okay, so now it's asking me to find k. So forget about this whole thing now. I know this is still the square root of x function. I know the integral from 0 to k on x to the 1/2, or the square root of x, is equal to, I forgot my dx, is equal to 8/3. Now I know the area and I know the integral. The only thing I don't know is my limits. Okay, but I can still work out this problem now. It's just algebra solving for an unknown variable. The antiderivative of x to the 1/2 is still 2/3 x to the 3/2. And we're evaluating that from 0 to k, and we know it equals 8/3. So on the left side here, we're doing the fundamental theorem of calculus part 1. It's 2/3 times, plug in your upper limit first, minus plug in your lower limit. We know if we plug in 0, we're going to get 0, and that equals 8/3. Now I'm just solving for k. Okay, so I'm going to get this 2/3 to the other side first by multiplying by 3/2. And 8/3 times 3/2 is 4. So I have k to the 3/2 equals 4. And to get rid of an exponent of 3/2, I raised both sides to an exponent of 2/3. K to the 3/2 to the 2/3 is just K. And now I have 4 to the 2/3. And there's several ways you can write 4 to the 2/3. I chose to write it as the cube root of 16, I believe. But 4 to the 2/3 is the cube root of 4 squared. And that's how I came up with the cube root of 16. Like I said, hardest one on there. But if we understand how to set up the integrals, okay, and we draw a picture, it makes it a little easier. All right. 5, 6, 7, and 8. I just want to point out on 5, I just want to make this a reminder and a special point of interest here is when our top and bottom are switching, it's when we can do absolute value. So we can do the absolute value of our integral, and then we only have to do 1. So we don't have to necessarily integrate from A to B and from B to C if we're switching, okay? Now, you cannot do an absolute value problem if you're doing it by hand, because we don't know the antiderivative of an absolute value function. But if you're doing it in the calculator, we can do it. Okay. And this is a calculator problem here. And you're only going to do the absolute value when your top and bottom are switching, not in any other case. All right. So questions on 5 or 6, how to set them up, put them in the calculator.
6.
6. All right. So find the area bounded by the graphs of y equals e to the x squared and y equals x plus 2. So the first thing I'm going to do is I'm going to my calculator and I'm graphing those. So in y1, I'm going to do e to the x squared. And in y2, I'm doing x plus 2. And I'm going to take a look at that graph. That's e to the x squared. And that's x plus 2. Okay, so I'm just going to sketch that on my paper just so I have an idea what we got going on here. But e to the x squared look like that. And x plus 2 looks something like that. Okay, so I had a little bit of area here, excuse me, a little bit of area here, and then all this area in here. I have to find this a value, and I have to find this b value so I can do my upper and lower limit. Okay, so in my calculator, let me zoom in so you can see this a little better. Okay, I'm going to go second calc, option 5, and I'm going to find the one on the left first. So the calculator says I'm on y1, enter. Calculator says I'm on y2, enter. And I'm going to move my cursor to the left so it's closer to this intersection point. Okay, so I'm looking at this intersection point right here, and then I'm going to hit enter. Okay, it tells me that that number is negative 0.587 as an x value. Okay, it's a decimal that never terminates. Okay, so I need to store that so I can save that. I'm going to store that in A. So I'm going to immediately hit quit. And I'm just going to hit store alpha math for A and hit enter. And then I'm going to write it down on my paper. Okay, because I have to write that down on my paper. If you don't write it on your paper, then they don't know what you're talking about. Okay, unless you actually write out all the numbers. Okay, so I'm just going to write here A is equal to negative 0.5876. Then I'm going to go find my B value.
Can you show me how you stored A again?
Yeah, how you store A. So once you're in your graph and you find your point, okay, so we've found the intersection point. Okay, it's written right down here. Okay,
Yeah.
that's the X value of my intersection. I'm immediately going to quit. So second mode to go to the home screen and then just hit store, which is right here next to the 1. You hit store and we'll say answer. We're going to store the answer. And now I'm going to hit any letter I want. So it's all these green letters, A,
Oh,
B,
okay.
C. I'm going to just hit alpha A. So it stores it in A. Okay. And then I'm going to write A. If you want to call this G, then you could do it, call it G and write and store it in alpha G, right? You just hit alpha and G is the tangent button. So you would store it there. Okay. Doesn't matter where you store it, just as long as you keep it in your head where you have it. All right. So we're going to do the same thing for the intersection point on the right-hand side. So we're going to go second calc option 5. First curve is Y1, second curve is Y2, but notice where my cursor is. If I hit enter right now on guess, it's going to give me the same answer again. So I want to move my cursor so it's closer and I try to get right on top of the other intersection point right here. So see, I'm going left and right with my cursor, right? I want to definitely be closer to this guy. Okay. Then I'm going to hit enter. And again, it's going to put the answer down here on the bottom of my screen at 1.057. So maybe I write that down first. It doesn't matter the order that you write them down, the order that you store them in. And now I'm going to hit quit and store that one in B, which is alpha apps. And so now I have my 2 values stored in my calculator. I'm going to put my calculator to the side for just a minute. And I need to write the integral on the paper. Okay, so the area is equal to the integral from A to B. And if you want to write the numbers here, you can. You can write negative 0.5876 here and 1.057 here. And then I look at my graph and I say the line is on top of the e to the x function. So it's x. I don't even have to write that. I can just say, well, I have to write them out. If they don't call these f of x and g of x and they call them both y, you have to write them out. Okay. So it's x plus 2 minus e to the x squared dx. But the actual work is going to be all done in a calculator. Okay, I like to have a nice clean screen. So I'm going to do that. And then I'm going to do from my home screen, math option 9. I'm going to put A on the bottom. So alpha math on the bottom. I'm going to put B up top. So it was alpha apps. Now I don't have to type in the function. I could just do, I don't even remember where I put what in. I think I did e to the x squared in y1. So mine would actually be y2 minus y1, but it might be easier to just type it in sometimes if you can't remember. X plus 2 minus e to the x squared. It actually doesn't take as much time, or maybe just about the same time, to type this particular function in as opposed to typing y2 minus y1 in. Okay. It's your call on what is faster or what you prefer. You could pick the slower one if you want. I'm just trying to save you time. And then put our x in our dx, and then we get our answer of 1.385. All right, 7 or 8.
Mr. Masson,
Yes.
on number 8, I got the right answer, but I got negative. Is it not supposed to be g of x minus f of x?
It is supposed to be f of x minus g of x. Okay, so here's what the graph on number 8 looks like. The graph of x squared minus 2 looks like that. That's at negative 2, right? That's actually my vertex, but close enough, right? And then the graph of the cube root of x looks like that. So the cube root of x is on top. And then you found your a and your b. So it's the integral a to b cube root of x minus x squared minus 2, or cube root of x minus x squared plus 2 if you wanted to distribute, if you wanted to type it into your calculator that way. Again, I would type it in like you said, but it is, if this is y1 and this is y2, it's y2 minus it's y1 minus y2.
Okay, thank you.
Yeah, no problem. Understand this, okay? If you get a negative answer, you did it wrong because we all know that area has to be positive, right? Okay. Now, totally different from when we're saying area under the curve is negative back in last applications, right? When we're talking about a particle moving left and right, okay? The area is total, like your total distance traveled or your displacement. So you can be negative there. But in this situation where we're actually physically finding an actual area, it has to be positive all the time. And when you do top minus bottom, if you do top minus bottom correctly, it has to be positive. All right, anybody for 7 or are we good there? All right, there's actually no point in doing it. So, because we're not going to get through the notes today. So we'll just call it quits there today. That was my plan yesterday. Yesterday went faster than I thought. Today went slower than I thought. So we'll call it there. And then we'll start the next notes on the next section tomorrow. Have a great day.
Before you end it, can you do 7 for me?
Yeah, I'm just going to hit stop record. No, I'll keep recording. All right, so 7. So I go graph 7 in my calculator is the first thing I want to do. Obviously, since we're allowed to use the calculator, we're going to take full advantage. Okay, so the first function is sine x squared. So not sine squared x, but sine x squared. So this truly is an x squared inside the parenthesis. And my other function is 1 minus x squared. All right, I'm going to graph that in the window that I have here. And obviously I see that in that window, it absolutely sucks, right?
Yeah.
But I know that I only want to see this part of the graph where they're intersecting, right? And I can see this, okay? So what I'm going to do is I'm going to change my window because I can see that going from -1 to 1, or is that -2? That's probably -1 right there. -1 to 1 is going to be good enough. So I'm going to go to my window and on the X, or excuse me, yeah, on X, I'm going to go from -1 to 1. Okay. Not that this is necessary, but it helps. Okay. Because we don't want to see all that other stuff that was going on anyway. That actually doesn't help too much because the Y's are not really good either. So let's change our Y's to go from like -2 to 2. Now we're going to see a better picture right here. Okay. So I just kind of play with my window until I get a good picture, but there it is right there. Perfect. Right. Now we're seeing the left side and the right side where we intersect, and we got everything, right? So we sketch the picture and literally it just looks like this and it looks like this. So I got to find that A and that B. I'll call that A, I'll call that B. So in my calculator, I want to find the one on the left first. So second calc option 5. First curve is Y1, second curve is Y2. Got to move my cursor to the left. And I like to get them like real close to the answer. Okay, so right around there is the intersection. I hit enter and I get that decimal down there on the bottom left, X equals. It's -0.7148. So I can write down A equals -0.7148. And I've got to store that answer. So now I'm going to quit out of that and go store alpha A. It didn't hit store. So try that again. Store alpha A. And so now A is stored. Back to the graph. And now I got to store the B value over here. So I'm going to go second calc option 5 again. First curve is Y1. Second curve is Y2. And then I got to move my cursor now all the way over to the other side, which, by the way, the answer is going to be the same as the other answer, but positive. I just know that. Okay, so I get 0.7148. And I'm going to store that in B. So quit, store in B. And so I've stored my answers. And now I look at my picture, right? I gotta look at my picture and figure out who's on top and who's on the bottom. And it's the 1 minus x squared is on top. And if you don't realize it, then you just go to the graph. Okay, do you have a colored calculator or non-colored?
Non-colored.
Okay, so what you need to do is you need to make sure when it's actually sketching the graph that you pay attention to who's on top, who's on bottom. Okay, so when you initially typed in y1 and y2, it's always going to graph y1 first. And in my case, it was the blue one, but you would just notice that this one is the one graphed first and this one's the one that graphed second. So my y2 is actually on top, right? You just figure that out. So the 1 minus x squared is on top. Now, they didn't call it f of x and g of x, so we do have to write them out. So it's the integral a to b 1 minus x squared minus sine x squared dx. And then you just type in your calculator, you could type in and you're going to do y2 minus y1. You wouldn't necessarily have to type this in again. So I would go to my home screen and just do second calc option. No, I wouldn't do that. I would do math option 9. And then I'm going A to B. Hit the wrong thing there. To B. And then y2 minus y1 dx. And I get 0.947. Is it a calculator issue or is it the integral issue or the A and the B issue or what minus what? Or everything?
To be honest, I just didn't know which area we were finding.
Okay. It's when you draw your pic, I get it on that first picture, right? That's hard because you see that, but you got to find, like when we first graphed it, you're just finding the intersection. So all this stuff is nice, fine and dandy, all weird, wacko stuff, but I'm focused on where the two graphs intersect. And if you see, like, even though we're on this funky picture, they're intersecting here and here. So it's the area in between. And then once I've narrowed it down, I know that it's always the area in between the two graphs. Okay. So like on this number 8 right here, it's this area right here, the area in between the cubic function and the other function. It's always in between them. Okay. Not above, not below, always in between. Sound good?
Yep. Thank you.
All right. Anything else from anybody in the gallery?